Hello students, now we are starting the problems of the NCERT and the topic is metals and non-metals. Now we are starting with some subjective questions that is given in the page number 56 in the NCERT. Now the question number 6, that is a subjective question. What are amphoteric oxides? What are amphoteric oxides? Give two examples of amphoteric oxides. So let's discuss the answer of this problem. First we discuss what's the meaning of oxide. Do you know that oxygen is the element? Now, when this oxygen combine with the metals and non-metals, metals and non-metals except fluorine, then the compound is called oxide. For example, if we are taking the example of metals like sodium, now when the sodium combined with this oxygen, it gives a compound sodium Na2O. Now this compound is called sodium oxide. We are taking another example like carbon. When this combined with oxygen, it gives a CO2. It is also called carbon dioxide. In these two compounds, oxygen is combined with the sodium, and the second example is oxygen combined with non-metals, but both are called oxide. The first one is called metal oxide and the second one is called non-metal oxide. But when we have taken the fluorine in the non-metal, like this fluorine react with oxygen, now this form OF2. In that case, this compound is not called oxide. Basically, this is called fluoride. Why? Since we are knowing that in electronegativity scale, the highest electronegative element is fluorine and then oxygen, then nitrogen. So that ide, when we are using the ide, that ide suffix usage for that element which having more En. If we are taking the example of sodium and oxygen, so in that case, En of the oxygen is more than sodium. So that's why it is called sodium oxide. Now in that case, suffix id added with the oxygen. In the second case, when we are taking the example of carbon, now in that case, En of the oxygen is more than carbon. So now again we are added oxide. Now again we are added suffix id with the oxygen. So that's why it's again called carbon dioxide. But when we are taking the fluorine, now in that case, En of the fluorine is more than oxygen. So the suffix ide added with the fluorine. Now the naming of this compound is oxygen difluoride. So I think it's a clear what's the meaning of oxide. Now we are having two types of oxide, that is metal oxide and non-metal oxide. Now if we are taking the case of metal oxide like sodium oxide or any other metal oxide, magnesium oxide, when these oxide dissolve in water, like when we are dissolving sodium oxide in water or magnesium oxide in water, then it gives a sodium hydroxide. Now this magnesium gives a magnesium hydroxide. Now when this oxide dissolve in water, then they gives the OH negative ion. So that's why we are saying that metal oxide are basic in nature, since they are giving OH negative when dissolve in water. Now if we are taking the non-metal oxide like carbon dioxide, now this carbon dioxide dissolve in water, it gives carbonic acid H2CO3. Now this carbonic acid gives H plus, so we can say that non-metal oxide are acidic in nature. Why? Since when non-metal oxide dissolve in water, then they gives acid and acid finally gives H plus. So we can say that non-metal oxides are acidic. Now when we are dissolve metal oxide in water, then they give metal hydroxide and metal hydroxide gives OH negative ions. So we can say that metal oxide are basic in nature, but Non-metal oxide are acidic in nature, but there are so many examples. Like, for example, if we are taking the metal oxide of aluminium, like aluminium Al2O3 is the oxide of aluminium. Now, when this dissolve in the water, so no doubt it gives aluminium hydroxide. So we are saying that it's the basic nature. Now what happens when this aluminium oxide react with the sodium hydroxide aqueous. Now we are knowing that it's the base sodium hydroxide. Now in that case, this aluminium oxide acting as an acid now forms a compound that called sodium metaluminate NaAlO2 plus hydrogen gas. So in that case, this hydrogen gas liberated due to this aluminium oxide. Actually, what happened when this aluminium oxide react with Al2O3? So first, this aluminium oxide react with this aqueous NaOH and gives a aluminium trihydroxide. Now this aluminum trihydroxide further react with NaOH. NaOH. Now, after that, it gives sodium meta-aluminate with the evolution of hydrogen gas. Now, in that case, this hydrogen gas liberated by this from aluminium. So, we can say that in that case, this is behaving as an acid. But when this aluminium hydroxide react with the acid like HCl, now it gives a salt that is AlCl3 plus H2O. In that case, that is acting as a base since it gives OH negative ion and this HCl acting as an acid. So we can say that aluminium oxide is a amphoteric oxide. Now, what's the meaning of amphoteric oxide? Amphoteric oxide are those oxides which act behave both like acid as well as base. So there are some metal oxide which are behaves like both acid and base. In that metal oxide, the first example is aluminum oxide. Now another example of amphoteric oxides are